Well, we finished off this section with recording 1D on working with radicals for Unit 5, Chapter 5 of Mathematics 2200. We focus here on like radicals and adding and subtracting radicals. Like radicals have the same index and the same radicand. For example, 5 times the square root of 3 would be like 6 times the square root of 3. They would be considered like radicals. They have the same index. The index is 2, and they both have the same radicands. Doesn't matter that the coefficients are different. Likewise, if I had 7 cube root of 4 and negative 3 cube root of 4, they would be like. On the other hand, if I had 5 times the 4th root of 3 and 6 root 3, they would be unlike. If I had 7 times the cube root of 4 and negative 3 times the cube root of 5, those would be unlike. These two don't have the same radicand. These two have the same radicand, but they don't have the same index. Now, when we have like radicals, we can add and subtract them by adding and subtracting coefficients, much like we would do for terms containing variables. So, for example, if we had 2x plus 7x minus 6x, we would simply say 2 plus 7 is 9, minus 6 is 3x. Well, it will be the same thing here in part A. 2 cube root of 5 plus 7 cube root of 5 minus 6 cube root of 5. We simply add and subtract the coefficients. So add, subtract coefficients. So that we get 3 cube root of 5. Meanwhile, in the next one, we've got 4 square root of 3 plus 2 root 5 minus 7 root 3 plus 6 root 5. So we get the like radicals together, just like if we had x's and y's instead. So we have 4 root 3 minus 7 root 3, they're like, plus 2 root 5 plus 6 root 5. So I simply grouped the like terms together, the like radicals. Now I subtract my coefficients. 4 minus 7 is negative 3 root 3, and 2 root 5 plus 6 root 5 would be 8 root 5. In this next one, it looks like nothing, and none of the radicals are like. However, there's a catch. We can see if we can express any of these as simpler mixed radicals. So we express each one in simplest mixed radical form. The largest perfect square factor or perfect square root that goes into the square root of 27 is square root of 9. So we have square root of 9 times 3 there. 3 root 5, well, root 5 does not have any perfect square factor beyond a 1. So we leave that one as it is. The 80 we can think of as square root of 16 times the square root of 5. And the 12. Okay, plus 2 root 4 times root 3. Move things over a little bit because it's encroaching on the next section here. There we go. That's better. Now, square root of 9 is 3, so we really have negative 3 root 3 here, plus 3 root 5 minus root of 16 times root of 5 will give us 4 root 5. This last one, I really have 2 times square root of 4 is 2 times root 3. So for that last term, I really have a 4 root 3. So I've repeated that same step, but that's a 4 root 3 there. My like radicals now are a little bit more visible. negative 3 root 3 plus 4 root 3. They get added. Plus, we have 3 root 5 minus 4 root 5. They are the like radicals. Negative 3 plus 4 is 1, so we have just a root 3, 1 root 3, or just a root 3. And 3 root 5 minus 4 root 5 is negative root 5. For the next one, we have some variables involved here. We'll do some separation. First of all, we have root of 20 times the root of x minus 3 times root 45 times root of x. The restriction, you'll notice, is already taken care of for us. Square root of 20, the largest perfect square root that will go into the square root of 20 is square root of 4. So we have root of 4 times root of 5 times the root of x minus 3 times the square root of 9 is the largest perfect square root that goes into the square root of 49. And we have root 5 there times root of x. Square root of 4 is 2. The root of 5 and the root of x can go back together because we can't do anything further with them, so we recombine them. And square root of 9 is 3, so we have 3 times 3, and we recombine the 5x here. Or the 5 and the x, rather. So we've really got 2 root 5x minus 9 root 5x. They're now like radicals. 2 minus 9 is negative 7 root 5x. And I'll restate the restriction that was given to us. X is greater than or equal to 0. In conclusion, like radicals have the same index and the same radicand. Like radicals can be added and subtracted by adding and subtracting the coefficients in much the same manner as like terms. And sometimes unlike radicals can become like radicals when converted to their mixed radical forms.